Hello everyone, this is Dharamveer sir here. So today we are going to start chapter 9 of grade 11 maths, which is sequence and series. And the topic of today's video is arithmetic progression. Okay, so let's start. So first let me tell you what is an arithmetic progression. And I know that all of you have gone through this topic in grade 10th. It was there AP chapter 5. So arithmetic progression is a sequence, the arrangement of number in which each term except the first is obtained by adding or subtracting a fixed number to the preceding one. Thus the sequence a1, a2, a3 up to an is called an arithmetic progression if an plus 1 will be equal to an plus some common number d, where d is called the common difference of the AP. Usually we denote the first term by a and the last term by l. Now the general term, we all know this formula, general term and term of the AP is given by an equals to a plus n minus 1 into d, and the last term and the nth term from the last is given by an equals to l minus n minus 1 into t. We also have the formula of the sum of n terms. So sum of n terms of an AP is given by Sn equals to n by 2 2a plus n minus 1 into d, which can be written as n by 2 into a plus l, where l is the last term. And also the general term can be obtained by an equals to Sn minus 1. Okay, so pause and note down these points. Coming to the next topic, which is arithmetic mean. Now arithmetic mean, it simply means average. Mean means average. So arithmetic mean of n positive numbers from a1, a2 up to an is given by am equals to a1 plus a2 plus a3 up to plus an upon n. That is sum of all the numbers upon total numbers. Clear? And if we have three numbers a, capital A and b in AP, then a is called the arithmetic mean of small a and b, and it is given by a is equal to a plus b upon 2. So whenever we have to find arithmetic mean of two numbers, simply add these two and divide by 2. Clear? So pause and note down these points. Now few important points to remember: that if the terms of an AP are increased, decreased, multiplied or divided by the same constant, then they still remain in AP. That is, if you divide all the terms or add all the terms, subtract and divide a constant number in all, then it will remain AP. So if a1, a2 up to a3 and so on are in AP with common difference d, then a1 plus minus k, a2 plus minus k, a3 plus minus k will also remain in AP, where k is the common difference. Sorry, k is some constant, and a1k, a2k, a3k and also in AP where k is some constant, and this time the common difference will be d into k. And if a1 upon k, a2 upon k, a3 upon k also in AP with the common difference d upon k. Now if a1, a2, a3 up to and so on and b1, b2, b3 are two APs, then a1 plus minus b1, a2 plus minus b2, a3 plus minus b3 and so on are also in AP. And their multiplication, that is a1, b1, a2, b2, a3, b3, and their division, that is a1 upon b1, a2 upon b2, a3 upon bb will also remain in AP. Clear? So note down these points. So if a1, a2 up to a3 and so on are in AP, then a1 plus an will be equal to a2 plus an minus 1 plus a3 plus an minus 2 and so on. ar equals to ar minus k plus ar plus k upon 2. And if the nth term of any sequence in linear expression is n, then the sequence is an AP. If the nth term is n, then it will be an AP. If the sum of n terms of any sequence is quadratic equation in expression in square, then the sequence is also an AP. Clear? So note down these points. So let's start exercise 9.2. And the question 1 is, find the sum of odd integers from 1 to 2001. So we have from 1 to 2001, so both numbers will be included. So we can simply check that this is an arithmetic progression where a is equal to 1 and d is equal to what? 3 minus 1 or 5 minus 3 equals to 2. And an, that is the last term, nth term is 2001. So we can find the value of n using the formula of an. So using an equals to a plus n minus 1 into d, we get 1 plus n minus 1 into 2 equals to 2001. So simplifying this, we will find the value of n as n equals to 1001. So since we have n, we have a, we have d, so we can simplify the sum of the AP, that is Sn equals to n by 2 a plus l, since we have first term and last term as well. So putting the values of n, a and l, we get the sum as 100,200,1. Clear? You might be able to solve all these sums on your, because you have solved the sums like this in grade 10th. So pause and note down the solution. Next is question third. In an AP, the first term is 2 and the sum of the first 5 terms is 1/4 of the next 5 terms. We have to show that 20th term is minus 112. So here we have a is equal to, and let d be the common difference. Now we have given that sum of the first 5 is equal to 1/4 of the sum of the next 5. So first 5 means what? A1 plus A2, or here we have indicated by T1 plus T2 plus T3 plus T4 plus T5 equals to 1/4 of the next 5, that is T6 plus T7, T8, T9 up to T10. So putting the value using the formula of an, we get a plus d plus a plus 2d plus a plus 3d plus a plus 4d equals to 1/4 a plus 5d plus a plus 6d plus a plus 7d plus a plus 8d plus a plus 9d. Simplifying, we get 5a is equal to 10d equals to 1/4 5a plus 35d. So simplifying, we get 20a plus 40d equals to 5a plus 35d. And since we have the value of a is equal to, so we get 5d is equal to minus 15 into 2, that is minus 30. So we have d is equal to minus 6. Now we have to find the 20th term. So t20 or a20 equals to a plus 20 minus 1 into d. So a is equal to 2 and d is equal to minus 6. Putting these values, we get the 20th term as minus 112, and this was our required proof. Okay, so pause and note down the solution. Okay, next is question number 5. In an AP, if pth term is 1 upon q and qth term is 1 upon p, then prove that the sum of first pq terms is 1/2 pq plus 1, where p is not equal to q. Now we have AP, that is the first term, is equal to 1 upon q, and AQ, that is the qth term, is equal to 1 upon p. So using the formula of an equals to a plus n minus 1 into d, we get a plus p minus 1 into d equals to 1 upon q, and a plus q minus 1 into d is equal to 1 upon p, where a and d are the first term and the common difference respectively. So subtracting 2 from 1, we eliminated a, so we get, on simplification, p minus q into d is equal to p minus q upon pq. So dividing by p minus q, which is non-zero, then d is equal to what? 1 upon pq. So putting the value of d in equation 1, we get the value of a as a is equal to 1 upon pq. Now putting these values of a is equal to 1 upon pq and d is equal to 1 upon pq, and n equals to v into q, we get Sn equals to n by 2, 2a plus n minus 1 into d. And putting all the values a, d and n, since we have to find the sum of pq term, so as it becomes pq upon 2 into 2 into 1 upon pq plus pq minus 1 into 1 upon q. So simplifying, we will get our required sum, that is 1 upon 2 pq plus 1. Clear? So pause and note down the solution. Next we have question number 7. Find the sum of n terms of an AP whose kth term is 5k plus 1. Now here we have kth term, that is ak equals to 5k plus 1. So putting k equals to 1 and k is equal to n, we get a, that is first term, is equals to 6, and an, that is nth term, equals to 5n plus 1. So Sn equals to what? N upon 2a plus an, last term. So we get n by 2, 6 plus 5n plus 1, that is n by 2, 5n plus 7. So this is our required sum of nth term. Clear? So pause and note down the solution. Next we have question number 9. The sum of n terms of two arithmetic progressions are in the ratio 5n plus 1 ratio 9n plus 6. So we have to find the ratio of the 18th term. Now let a1, a2 be the first terms and d1, d2 be the common differences of both the APs. So according to the given condition, we have sum of n terms of the first and sum of n terms of the second equals to 5n plus 4 upon 9n plus 6. So applying the formula of Sn, we get n by 2, 2a1 plus n minus 1 into d1 upon n by 2, 2a1 plus n minus 1 into d2 equals to 5n plus 4 upon 9 plus 6. So cancelling, we get 2a1 plus n minus 1 d1 upon 2a2 plus n minus 1 d2 equals to 5n plus 4 upon 9n plus 6. So we have to find the ratio of 18th term, that is 18th term of the first AP on 18th term of the second AP. That will be equal to a plus 17 d1, sorry, a1 plus 17 d1 upon a2 plus 17 d2. So multiplying both the numerator and denominator by 2, we get 2a1 plus 34 d1 upon 2a2 plus 34 d2. Now comparing it with the LHS of equation 1, we have n minus 1 equals to what? 34. So n equals to 35. So putting n equals 35 on both sides of the equation 1, we get 2a1 plus 34d1 upon 2a2 plus 34d2 equals to 5 into 35 plus 4 upon 9 into 35 plus 6 equals to 179 upon 321. So we get the 18th term of the AP. First AP upon 18th of the second AP equals to 179 upon 321. Clear? So pause and note down the solution. So moving to question 12. The ratio of the sum of m and n terms of an AP is m square ratio n square. Show that the ratio of the mth and nth term is 2m minus 1 ratio 2m minus 1. This is same like previous sum. So let a be the first term and d be the common difference of the AP. So by the given condition we have sum of m upon sum of n equals to m square upon n square. So using the formula of sum we get m by 2 2a plus m minus 1 into d upon n by 2 2a plus n minus 1 into d, which is equal to m square upon n square. So dividing we get 2a plus m minus 1 into d upon 2a plus m minus 1 into d equals to m by n, or we get 2a plus md minus d upon 2a plus nd minus d equals to m upon n. Just open the bracket. So cross multiplying we get 2an plus mnd minus nd equals to 2am plus mnd minus md. So simplifying we get 2a into n minus 1 equals to n minus 1 into d. So we get d equals to 2a. So term n, mth term upon nth term equals to what? A plus m minus 1 d upon a plus n minus 1 into d. So using d equals to 2a, we get a plus m minus 1 into 2a upon a plus n minus 1 into 2a. On simplifying we will get 2m minus 1 upon 2n minus 1, that the ratio of their mth and nth term will be equal to 2m minus 1 ratio 2n minus 1. Okay, so pause and note down the solution. Moving to question 14. Insert 5 numbers between 8 and 26 such that the resulting sequence is an AP. So let the 5 numbers are A1, A2, A3, A4 up to A5 between 8 and 26. Now according to the given condition 8, A1, A2, A3, A4, A5 up to 26 are in AP. So it is an AP. Therefore numbers will be n plus 2, that is we have 7 numbers over here. So A is equal to 8 and B is equal to 26. And n equals to 7. So a7 equals to 26. So 8 plus 6d is equal to 26. So we get the value of d is equal to 3. Now a1 equals to what? Term 2, which is equal to a plus d, that is 8 plus 3, 11. Same a2 is term 3, so a plus 2d, which is equal to 14. a3 is our term 3, so a plus 3d equals to 17. a4 is our fifth term, so a plus 4d equals to 20. a5, that is our sixth term, so we have a plus 5d, which is equal to 23. So the required 5 numbers will be 11, 14, 17, 20 and 23. Clear? So pause and note down the solution. Moving to question 15. If a power n plus b power n upon a power n minus 1 plus b power n minus 1 is the am between a and b, then find the value of n. Am means arithmetic mean. So we have given that a power n plus b power n upon a power n minus 1 plus b power n minus 1 equals to a plus b upon 2. So simply cross multiply. We get 2 a power n plus 2 b power n equals to a power n plus ab power n minus 1 plus ba power n minus 1 plus bn. So on transposing we get 2a power n minus a power n plus 2b power n minus b power n equals to ab power n minus 1 plus ba power n minus 1. So we get a power n plus b power n equals to ab power n minus 1 plus ba power n minus 1. So on simplifying we will get a power n minus 1 equals to b power n minus 1, and transposition we will get a upon b whole power n minus 1 equals to 1, which is equal to a upon b power 0. Base is same, so exponent should be equals n minus 1 equals 0, so n equals to what? 1. So this is the required value of n. Clear? So pause and note down the solution. Next is question 17. A man starts repaying a loan as first installment of rupees 100. If he increases the installment by rupees 5 every month, what amount he will pay in the 30th installment? Very easy sum. So we have the first installment as 100, next we have 105, next we have 110. So we have a is equal to what? 100 and d is equal to 5. Very simple. Now we have to find the 30th installment, that is a30, 30th term of the AP. So applying the formula of an, we get a30 equals to a plus 29d. So 100 plus 29 into 5, which is equal to 245. So the amount in the 30th installment will be 245. Clear? So pause and note down the solution. With this we end the exercise 9.2. So solve the remaining sums of the exercise and also the examples given before the exercise. Okay, thank you and all the best.